What is momentum? Let's consider that two objects are falling down from a height of 200 meters. Let the mass of this object is 5 kg and the mass of this object is 50 kg. These both bodies accelerate with the same speed towards Earth. If I ask you to catch one object out of these two objects, which object would you choose to catch? I am sure you will choose the object of mass 5 kg. Is it because the mass of 5 kg is less than 50 kg? The answer in physics is no. It is because the momentum of 5 kg body is less than the momentum of 50 kg object. In physics, we define momentum as the cross product of mass and velocity. We denote momentum by P. Hence, P is equal to mass and to velocity. We know that velocity is a vector quantity. Hence, momentum is also a vector quantity. The direction of momentum is same as the direction of the velocity. Now, how can we calculate the SI unit of momentum? As we know that momentum is equal to mass into velocity. Our momentum is equal to m and to v. The SI unit of mass is kg and the SI unit of velocity is meter per second. Hence, the SI unit of momentum is kg meter per second. This unit of momentum tells us just the quantity of a motion present in a body or in a mass. Now, how can we calculate the momentum of an object? Let me give you two cases. In case 1, if a person is standing on a road, suddenly a bicycle of mass 50 kg moving with a velocity of 60 meters per second hits the person. As a common observation, the person would only be injured. Now consider the same person in case 2. If this person is standing on a road, now suddenly a truck of 2500 kg moving with the same velocity of 60 meters per second hits the person. As a common observation, the person may die. Can you guess that a person in case 1 is only or merely injured, while the person in case 2 is either died or in serious condition? Although both the bicycle and truck were moving with the same velocity of 60 meters per second. I hope that your answer would be the difference in masses. If it is so, then you are 100% right. Let me explain these two cases in physics. In case 1, the mass of bicycle is 50 kg. It means mass is equal to 50 kg and its velocity v is equal to 60 meters per second. Hence, the momentum p of the bicycle is equal to mass of the bicycle and the velocity of the bicycle. Now putting values in the formula. P is equal to 50 kg and to 60 meters per second. We get 3000 kg meter per second. Hence, the momentum of bicycle is 3000 kg meter per second. In case 2, the mass of truck m is equal to 2500 kg, while the velocity of the truck is 60 meters per second. Hence, the momentum of truck p is equal to mass of the truck and to velocity of the truck. Thus, p is equal to 2500 kg and to 60 meters per second. We get p is equal to 150,000 kg meter per second. So the momentum of truck is 150,000 kg meter per second. This shows that the momentum of a bicycle is smaller than that of the momentum of a truck. Therefore, a person is merely injured in case 1, when it was hit by the bicycle, while in case 2, the person got serious injuries or death when it was hit by the truck. At last, let me teach you, does a stationary body possesses momentum? To answer this question, let me give you another example. If a car of mass m is stationary or at rest, its velocity v is equal to 0 meter per second. Hence, its momentum is equal to P is equal to m into v. Thus, P is equal to m into 0, or P is equal to 0 kg meter per second. It shows that if an object is at rest, its momentum P would be 0, or we can say that the momentum P of an object would be 0 if the body is at rest. I hope you have learned the fundamental concept of momentum. Thank you very much for watching this video.
Impulse of a force. In case of a ball hit by a bat or driving a nail into the wooden block with a hammer, the force acts for a short time interval. This force varies with time, hence cannot be measured easily. In such cases, we measure the total effect of the force called as impulse of force. Consider an impulsive force vector F acting on a body of mass m for short time t. The velocity of the body changes from vector u to vector v. According to Newton's second law, vector F is equal to vector p2 minus vector p1 upon t. Impulse of the force or impulse vector F dot t is equal to vector p2 minus vector p1 that equals to vector j that equals to m vector v minus m vector u. This shows that impulse is equal to the change in linear momentum of the body. Impulse is a vector quantity. Its direction is same as that of the force. The SI unit of impulse is same as that of linear momentum, that is kg meters per second or Newton seconds. Dimensions of the impulse are L raised to 1, m raised to 1, t raised to minus 1.
Law of conservation of momentum. Objective: to learn the law of conservation of momentum. Momentum is defined as the motion of the mass of an object. Because all objects have mass, any moving object will also have momentum. The law of conservation of momentum states that the total momentum of two or more objects acting upon one another will not change, provided there are no external forces acting on them. In other words, when two objects collide, their total momentum before the collision will be the same as the total momentum after the collision. Let's consider two cars of different masses, a bigger one, M1, and a smaller one, M2. Imagine the cars are moving in the same direction, but with different velocities, u1 and u2 respectively. Because momentum is the product of mass and velocity, the momentum of the bigger car can be expressed as m1 into u1, and the momentum of the smaller car can be expressed as m2 into u2. To determine the total momentum of both cars would be m1 u1 plus m2 u2. Now, let's imagine that our two cars are colliding. During the collision, the bigger car will exert a force F1 on the smaller car, and the smaller car will exert a force F2 on the bigger car. As a result of the collisions, the velocities of the cars will change. So, we'll represent those as v1 and v2. Force is the product of mass and acceleration. In our example of the collision, the force of the bigger car will be expressed as F1 is equal to m1 into v1 minus u1 by t, with t representing time. The force of the smaller car during the collision will be expressed as F2 is equal to m2 into v2 minus u2 by t. According to the Newton's third law, each action will have an action that is equal and opposite, meaning the forces can be expressed as F1 is equal to minus F2. Because both forces are equal and opposite, we can also write them as m1 into v1 minus u1 by t is equal to minus m2 into v2 minus u2 by t. We can cancel t, the common factor of time in the equation. m1 into v1 minus u1 is equal to minus m2 into v2 minus u2. The equation can then be simplified. m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2. And it can be written as m1 into v1 plus m2 into v2 is equal to m2 into u2 plus m1 into u1. From this equation, we can see the total momentum for both cars before and after the collision did not change but was conserved, thereby proving the law of conservation of momentum. Summary. The law of conservation of momentum states that the total momentum of two or more objects acting upon each other does not change, provided no external forces act upon them.